Hey, hello.
Yes. So you are Jetsi, right?
Yes, sir, this is my portfolio.
Alright. Okay, let's start the interview with a simple question. So if your coworker was unsure about how to do something, how would you help them?
I wouldn't help him. He's him, I'm me. Who cares about him?
Next question. Hey, hello.
How's your interview?
These interviews are so bad. I don't know what to do with them. I think if I were to hire them,
Hey, you are a software engineer, right? Would you mind helping me with this? I can't seem to get our software to look for this.
Ha! Software engineer is just a status. I don't even have any experience in software engineering. It's just good interview skills and a little bit of pretending. And of course, ChatGPT to help me to get through my degree. Can't help you, I'm sorry.
I don't even want to imagine it, right?
Yeah, it's tough, bro. But I did hear that the high-ups are gonna do something about it, though.
Really?
Yeah, it's a real problem. Did you know a single bad hire at a manager level can cost $132,000? And the current average cost per hire has already reached $4,700, with time to hire increasing to 44 days alone. The trend has been increasing for 4 consecutive years, and in the latest report of 2024, it has shown a 60% increase. With 35% of recruiter time already used for interview scheduling alone, I bet that's something we can do, right? In today's day and age, organizations implementing AI-powered hiring tools are achieving remarkable results, seeing 85% shorter hiring cycles, 40% increased accuracy with using AI screening tools. And these tools are reflecting an accuracy rate of 89% to 94%. It also reflects a 30% lower cost in hiring. With predictive hiring technologies demonstrating 34% better quality of hires and 70% faster time to fill, the evidence is overwhelming. The future of recruitment speaks the language of linear regression across all data fields.
We then propose a feasible business solution of making an AI-driven integrated prediction platform. So, how does it work? Firstly is data integration. It collects and standardizes candidates' information such as age, education, experiences, and internship, followed by statistical modeling, applying the collected information into linear regression or other statistical model. Next is the AI-based prediction, generating a predicted performance index ranking candidates by their likelihood or success. Lastly is the recruiter dashboard, providing a transparent evidence-based shortlist of highly potential candidates. So, why did we choose linear regression? Linear regression quantifies how much and in what direction one factor affects the other, measuring the strength of relationships between dependent and independent variables, and connects these relationships to employable outcomes such as performance, retention, and interview success. Most importantly, it predicts future outcomes and identifies which variables have the most significant impact on the dependent variable. Hence, we have chosen linear regression as the core statistical approach for our solution.
On to our analysis, our dependent variable would be hiring decision y. We set our linear regression equation as y equals to b0, the intercept, plus b1 all the way to b7, where b1 to 7 are decided coefficients and the independent variables are, firstly, age, experience years, number of previous companies, distance in kilometers, skill score, gender of the candidate, and lastly, education level. So now how do I calculate this in R and get the relevant data that I need?
So firstly, I have to load and save the data. So I will use the code x equals to read.csv file, and I'll choose the file that contains the data that I'm using. Here I label it stats project. Next, to apply the linear regression formula, I will save it as hiring. And here you can see that the table that I need has come out. And now I have to check whether any of the data here is skewed. So to do that, I have to install the packages moments and open the library for moments to check whether there's any skewed data. As you can see, none of the data here is skewed. All the values are below 0.5.
Now let's find out which variable has a significant effect on hiring. We'll look at the coefficients and most importantly if the p-value is less than 0.05. Let's start off with the intercept, where its negative coefficient is that when all other variables are 0, the predicted hiring rate is slightly negative, but since significance doesn't apply to intercept, we can move on. Next, we'll be talking about age. The positive coefficient shows that when age increases, the hiring probability increases by 0.019% per year. However, the p-value being 0.877 is larger than 0.05, showing how it's not significant. Sadly, the saying of the older, the wiser doesn't apply here. Next is experience years. It has a positive coefficient and is highly significant as its p-value is 3.22 e to the power of -6. Every extra year of experience increases hiring rate by 1.16%. So yes, those unpaid internships are really needed. Moving to previous companies, it has a positive coefficient which shows that working in more companies increases probability of hiring by 0.98%. However, its p-value being 0.231 shows how there's no significant effect. Maybe employees prefer someone which shows more commitment. Next, distance from company. It has a negative coefficient which shows how greater distances lowers the probability of hiring by 0.054%. At the same time, its p-value of 0.491 shows that there's no significant effect. Therefore, whether you live nearby or in town, what matters is that you're on time. Now, skill score, which has a positive coefficient and is highly significant as its p-value is 5.44 e to the power of -16. Hence, each 1 point increase increases hiring probability by 0.32%, proving that skills really do speak louder than words. Next, gender, where male is coded as 1 and female is coded as 0. Its positive coefficient shows that males have a higher hiring rate of 0.00969%. However, its p-value being 0.997 shows that this effect is not significant. Therefore, gender doesn't influence hiring, and we aim to create equality in the workplace. Lastly, education. It has a positive coefficient and is highly significant due to its p-value of 7.58 e to the power of -9. This shows that one level increase in education raises probability of hiring by 5.42%, showing that studying truly pays off. To wrap it up, the three significant predictors are experience years, skill score, and education levels, with all p-values below 0.05.
Now that the key factors that have been identified, Insight HR uses our linear regression model as its prediction engine. It applies higher weights to the strongest predictors, so candidates with better education, experience, or skill scores naturally will receive higher PPI scores. This lets the AI shortlist based on evidence, not assumptions. Insight HR then automatically collects and encodes all candidate data in the same structure as the model, ensuring consistent and reliable inputs. Using those learned weights, the AI instantly scores every new applicant and identifies hiring patterns through their PPI score. The system also learns continuously. After each hire, it tracks real performance and updates the model automatically. If a factor becomes more or less important, Insight HR adjusts its weight, creating a feedback loop that keeps improving the system. We validated this in R, and the model achieved an R-square of 0.79, showing strong accuracy between predicted and real hiring outcomes. To stay effective, the AI regularly checks which factors remain relevant. Outdated or weak predictors are reduced or removed to keep the model fair and aligned with our current trends. In summary, Insight HR learns, tests, and updates itself through a full statistical feedback loop, giving organizations a hiring system that is efficient, unbiased, and always improving.
All in all, we've come up with our solution by identifying an issue in the workplace and analyzing the relevant data. Our analysis with linear regression shows that hiring outcomes can be predicted more accurately by focusing on significant independent variables like experience years, skill score, and educational level, while insignificant factors like age, gender, previous companies, and distance should not be a priority. Building on this, our AI-driven prediction platform then prioritizes the significant factors that by automatically shortlisting high-potential candidates for interviewing. This allows our tool to recommend optimal interview candidates, saving time and boosting hiring efficiency for companies. No need for meaningless, time-wasting interviews with candidates that we already know are not suitable. At the business level, firms with data-driven, AI-assisted selection processes report shorter hiring cycles, higher screening accuracy, lower recruitment costs, and better quality of hire. Our solution directly targets these outcomes, improving the hiring efficiency of a company. Let us see what our stress manager has to say about this solution.
So, it's your portfolio? So, first question, yes, thank you. If you were a co-worker struggling with something, how would you help them?
First of all, I will listen to their issue first. I will try my best to understand. Then, I will personally assist them to the best of my ability. If I can't help, I'll get the help of other colleagues. If they are still stuck, I'll report it to the higher-ups for them.
Hey, how is it this time?
It's better than the previous time. That was like the best interview I ever got. Oh, this new system in place are really good.
Yay!